Tahniah! Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia, sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hi teachers and students, welcome to Pusat Tuisyen Academy YouTuber. Bermula percuma, selamanya percuma. How are you doing today? I hope all of you are ready for today's lesson. So before we begin, I have a few reminders to all of you. First, please use correct language in comments and suitable user profile for public view. Number two, regarding the certificate link, the link will be given at the end of our session. Please use e-didik account when you fill in your particulars. And I will give you the passcode also at the end of the lesson. Please fill in the form within the time limit, which is 30 minutes. So without further ado, let's begin the lesson for today. Okay, so today we will learn about atomic structure. Let's continue from the last week topic, which is the second part of the atomic structure. Before I begin the lesson, let me introduce myself first for those who still new to my channel. My name is Lau Chaiwi. I work in Pusat Tingkatan 6 SMK Pendidikan, and my teaching experience is 19 years. And my channel is Vivi Lau. Here you can see my channel. I have shared videos and notes in the channel. Please subscribe to my channel if you haven't done so. Next, I will introduce you to my PU team. And this is the playlist. Okay. You can access the playlist for many subjects of PU. Let's see, we have, first we have mathematics. Okay, then our Ketua Panitia for the PU is Teacher Im. She's teaching mathematics T with Teacher Eileen. And also we have Cikgu Zana, she's teaching mathematics M. Next we have biology. So my biology team is led by Cikgu Faiza. And we have Cikgu Fatia and Cikgu Naini. Last one, second last one, we have accounts led by Madam Fizi and Cikgu Yati. So last but not least, we have chemistry. So the chemistry department is led by Cikgu Shannon. We also have Teacher Tang and Cikgu Mawa and me. Okay. So if you want to know more about free online tuition, you can access the portal www.academyyoutuber.com. Okay, so now let's begin our lesson for today. So this is the second part of the chapter atomic structure. If you miss the first part, you can watch the video in my channel. So today we will learn about atomic orbitals S, P, and D. So for this subtopic, we will learn about how to reduce the number and relative energies of the S, P and D orbitals for the principal quantum numbers 1, 2, and 3, including the 4s orbitals. You also have to know how to describe the shape of the s and p orbitals. Next subtopic is the electronic configuration. So today we'll learn two subtopics. So in this subtopic, you have to learn how to predict the electronic configuration of atoms and ions given the proton number and charge. And also you have to know how to refine and apply the three principles. Aufbau principle, Hans rule, and Pauli exclusion principle. Okay, so first let's look at atomic orbitals. Oh, the screen is too small. Okay, wait first. Okay, I choose the wrong one. Okay, so it's okay now. Okay, so let's continue. Okay, so first we look at what is shell and subshell. So electrons are arranged around the nucleus of an atom in shells. The cells are numbered n equal to 1, 2, 3, etc. These numbers are known as principal quantum numbers. Okay, so remember we have learned in the last class, last week. So n is the principal quantum numbers. Each cell consists of a number of subcells labeled as S, P, D, or F. Hence, the first shell has one subshell, the second shell has two subcells, etc. We look at the table in the next slide. For the subcells. So, so for n equal to 1, shell n equal to 1, the subshell only have one S. So the maximum number of electrons they can fill in here is, you can use the formula 2n squared. So you will get 2 times 1 square, you will get 2. Okay, then second shell n equal to 2, you will get 2s and 2p subcells, 2 subcells. So 2 square, you will get 4, 4 times 2, you get 8. Okay, so the maximum number of electrons here is 8. Okay, then you have shell n equal to 3. So here we have 3s, 3p, and 3d. So the maximum number of electrons that can fill in here is 18. Then we have n equal to 4. So for 4 we have 4s, 4p, 4d, and 4f. So the maximum number of electrons we have 32. Okay, so okay, now we look at next slide. Okay, so you have to learn how to roll the energy levels of the orbitals. Okay. So so we start from the lowest energy. Okay, n equal to 1. 1 is the lowest energy, 1s. So closer to the nucleus that you learned last week. Then followed by n equal to 2, 2s. Okay, and 2p. Okay. Okay, then we have n equal to 3, 3s, and 3p. Okay, then you will notice that, okay, the 3d is higher than the 4s. Okay, so 4s has a lower energy than 3d. So when it's empty, okay, the 4s is below 3D, okay? And we have 4P, so here we don't show the 4D and 4F, okay? Okay, now we look at orbitals. The definition of orbitals. So orbital is defined as a region or volume of space within which there is a high probability, 95% chance of finding an electron. Okay. So we have two types of orbitals, S and P for STPN level. Then for matriculation, you have to learn SP and D orbitals for the shape. So tonight, I just share with you the S and P orbitals. So all the S orbitals are spheres. They only differ in size. Okay. The 3s orbital is bigger than the 2s, which is bigger than 1s. Okay, so when you draw, let me see. Okay, so when you draw the orbital, because I find the okay, so when you roll the s orbitals, you have to roll the 2s bigger than the 1s, then roll 3s bigger than 2s. Okay. Okay, next we look at the shapes of p orbitals. So p orbital is dumbbell shape. S orbital just now is a spherical shape. P orbitals is dumbbell shapes. So we have p orbitals that is directional. Okay, they have different orientation in space. So you have px and pz and py. So means if the orbitals at the s-axis lie on the s-axis is px. If the orbitals, p orbitals lie along the z-axis is pz. And the third one we have orbitals lie along the y-axis, that is py. Okay, so they all of the three orbitals have the same shape, dumbbell shape. Okay, so if you have compare 2p and 3p, like just now the s and 2s and 3s, 3p is bigger than the 2p. So when you roll, you will have to roll 3p bigger. Okay, so let's begin with the question number 1. So students, you can write your answer in the comments. Okay, so we look at the question. The first question is required to draw. Okay, never mind. So this one I will show you the answer, but you can do it on your paper first. Okay. So for orbitals, normally the question will ask you to draw and label all the valence orbitals of oxygen atoms. So be careful here. It's a valence orbitals. Okay. So you try to roughly know what is the valence orbital of oxygen atoms? Anyone know the valence orbital? You can write your answer in the comments. Valence orbitals. Anyone? So to know the valence orbital, first you must know the number of electrons. Okay. So to know the number of electrons, so you must know the proton number. Okay. So you can get proton number from the periodic table. Okay. So for atoms, the proton number equal to the number of electrons. So anyone know the valence orbitals here? You can write on the comments. So you have to refer to the periodic table if you have issue. Okay, or I give you the proton number. So the proton number of oxygen is P equal to 8. The proton number is 8 for oxygen. So what is the valence orbitals? 286. So what is the valence orbital? You write 2s. Okay. Your right answer is 2s2 2p4. Okay. Inside also 2s 2p4. Okay. So means you have to roll the s and p orbital. Very good. Okay. So you roll the s and p orbital. Anyone have other answer? Okay. So what are the shape? What is the shape of s orbital and p orbitals? You can write in the comment. Okay. So the shape is, so you have to know the number of photons, then you know number of electrons is 8. Okay, so you can see here we have valence. So 1s don't consider, no need to roll the 1s. Okay, so you just roll 2s and 2p. Okay, so you have to roll all the 3 orbitals of p, so you label it separately. Okay, so Gao Science answer 2s2 is circle. Okay, so very good. So you'll get 2s orbital is circle shape, or we say spherical sphere shape. Then we have 3 dumbbell shape, px. So very good, dumbbell shape. Okay. So we have 2px. You have to roll 2px, roll 2py, and roll the 2pz. Okay. So second method is you join, combine all the p orbitals together. Okay. Sorry, too fast. Okay, so you can roll like this. You can write separately the p orbitals, okay, or you can join up, okay, join up all the 3, okay, second method. So you must label and roll the 3 s's, label all the 3 s's, x, y, z, okay. If you don't want to roll the whole axis, you can roll little bit here also, okay. So the shape must be correct, okay. So normally for this one you can get 3 marks, okay. 1 mark for the label, okay. 1 mark for the spherical shape, 1 mark for the lumbar shape, 3 marks, okay. So if the question asks you to write, okay, if the question asks you to label all the orbitals, they didn't mention valence, so you have to roll the 1s, okay. But the 1s you have to roll smaller. So you label this one 2s, then you want roll one small 1s inside the 2s. Okay. So these are the type of question can come out. Okay, so question 2. Okay, so we look at the question. Where is the question? That's first one. Question 2. Sorry, there is a question. Okay, question 2, the question go too far. Okay, so I should decide. Okay, so we look at the question. So question 2, you are required to draw a label diagram to all the orbitals in the principal quantum number n equal to 2 in the atom. Draw a label diagram. Okay. So this question I give you because you have to look at the keywords here. Label diagram. Okay. So you have to draw only one. You have to join up the S. Okay. Join up the S and the p orbitals all together in one diagram. Not like just now. Just now is separate, right? Okay. You draw the S beside the dumbbell. So for this question, you have to be careful. Label diagram. So you have to join up the S and the P orbitals together. Okay. So like just now, also label all the S's. So label the 2px, 2py, and 2pz for the dumbbell, for the P orbitals dumbbell shape. Then label the S orbitals, 2s. Okay. So far, any question from the students? You understand? No question, Okay, so I continue. Okay, now we look at question 3. Okay, so question 3, we have this question as sketch the energy level diagram of the orbital of an atom which is not hydrogen for the principal quantum numbers n equal to 1 to n equal to 3. Okay, so they want the energy level diagram. Okay, so you do like just now. Okay, question 3. Answer. So you do like this. Okay, always have to label the energy. Okay, label energy has mark. Okay, then label, roll the 1s first. Follow the principal quantum number. 1 always nearest to the closer to the nucleus. So start from 1. So 1s first, 2s, then 2p, 3s, 3p, and 3d. So the question just want you to roll the energy level diagrams of n equal to 1 to n equal to 3. So you don't need to show the plot here. Okay. So before I continue with the electronic configuration, so let us watch the advertisement for a while. Okay.
Semua sekolah di
Alah, apa ni? PKPB lagi. SPM pula ditangguhkan. Jenuhlah nak bayar yuran tuition. Pernah dengar tentang tuition percuma? Kami di Akademi YouTuber menyediakan tuition online secara percuma kepada anda semua. Ada prasekolah, sekolah rendah, sekolah menengah, STPM, juga untuk matrikulasi. Percuma je. Jom layari laman sesawang www.academyyoutuber.com.
Okay, so welcome back, students. So now we continue with the second subtopic for today, electronic configurations. Okay, so there are 3 rules for determining the exact ground state electronic configuration of an element. So you have to know rule 1, outbound principle, rule 2, Pauli exclusion principle, and rule 3, Hans rule. Okay, so first we look at outbound principle. Okay, so this principle states that the electrons in their ground state occupy orbitals in order of the orbital energy levels. Okay, so you have to memorize the principle. Okay, because always the question will ask you to state the principle, define the principle. Okay, then explain the principle with examples. So you have to memorize the whole statement. You can your statement no need to exactly follow the sentence, but you must have the keywords here. So means the electrons in the ground state occupies orbitals in order of the orbital energy level. Okay, so we always fill up the lowest energy level first. Okay, so for example, you have to fill the electron in sequence of 1s to 2s, then to 2p, then 3s, 3p, 4s first, then followed by 3d. Okay, so look at this one. So alpha principle. So we have the Lagrange rule for electron filling order. Okay, so fill in the 1s first. Okay, so 1s can fill total 2 electrons. Okay, then 2s followed by 2p. Okay, after that 3s, then 3p followed by 4s. Okay, so 4s first, then 3d followed by 4p, then 5s first. Okay, okay, then 4d followed by 5p, then 6x, then 4f, 5d, 6p, 7s, okay, 5f, 60, 7p. Okay, so this is diagonal rule. So normally you have to roll like this. Like just solve the question 2 and question 3. Okay, so fill up the 1s first. Okay, then only fill up the 2s. Okay, then followed by 2p, then 3s, then 3p, then 4s, then 3d, then 4p. Okay, okay, so we look at the electronic configuration of ions. Okay, so for ions, first we look at the example, sodium atom. So sodium atom usually will donate 1 electron, okay, to become octet, okay, which is a stable configuration. So it will form this sodium ion. Then we have aluminum atoms donate 3 electrons. So it will form the neon. So this is we call neon configuration. Okay, so you can see here. So sodium lose 1 electron from the neon configuration. So we can say here sodium ion, aluminum ion, and neon are isoelectronic. Okay, so means they have the same configurations. So remember the word iso. Iso stands for same. Okay, so for anions, negative ions, we use a chlorine example. So chlorine need another 1 electron to achieve the neon configuration. So that one is for anion and cation. Okay, so far any question? from the students? Okay. Now we look at second rule. Okay, so second rule is Pauli exclusion principle. So this states that an orbital cannot contain more than 2 electrons, and then only if they have opposite spins. Okay. So we see example here, helium. So you can see here, you cannot write the spin the same direction. Either go up or go down also cannot. So you must use the opposite spin. So one orbital must have opposite spin. Very next one we have beryllium. Beryllium, the same thing, 2s. The spin must be opposite. Okay, next we have Hans rule. So Hans rule states that regenerate orbitals must be occupied singly and with parallel spins before they can be occupied in pairs. Okay, so regenerate orbitals here means it has the same energy level. Okay, so must occupy single first parallel spin, so which is more stable. Because in pairs they will repel each other. Okay, so example we look at foreigner. Okay, so we have fill up the one first, okay, then fill up the 2s. Okay, so here you can see must fill in singly first, okay, before fill up in pairs. So you fill in the orbital singly first. Okay. So next example, carbon, can see here. So you can see here, you cannot write this 2, okay? Means you must fill up the regenerate orbital 2p singly first, okay? But this one wrong also, okay? So this one also wrong first. Okay, so we look at this one. So, make some correction. So this one wrong. So I change it. Okay. Okay, so must opposite spin. Okay, so that's how. So we can write the spin going up or spin going down also can. But normally, the question will give you going up. But sometimes they give you this one. So means they give the spin, although it's going down, but it's parallel also can. Okay, so these two is accepted. But this one wrong. Okay, opposite spin cannot. So must be occupy single reverse with parallel spin, so same direction spin. So this one wrong also, okay? So any question? Okay, next example, common. Okay, so for the common is a special case, okay? So it will fill in the, okay, fill in the 3D singly, okay? Because half field 3D orbital is more stable. So the electron from the 4s at first is 2, right? Normally we have to fill up the 4s, only can fill in 3D, okay? According to the energy levels, but because of the spatial extra stability of the half field 3D, so one electron from the 4s will give to the 3D, okay? So the 3D has a half field 3D orbitals, not this one. This one partially filled is not stable, okay? So special case for chromium, and next special case is copper. Okay. So fully filled 3D orbital also non-stable. Okay. Okay, so the one electron go to the 3D. So means they don't follow the alpha principle. Okay. So this is because of the fully filled 3D orbitals and half filled 3D orbitals are stable. Okay, any question from the students? No question, okay. So we look at the question 4. Let's now until question 3. Okay, so which of the following is the ground state electronic configuration of sulfur? Okay, so sulfur proton number is 16. Okay, so students, you can write your answer in the chat. Okay, any answer from the student? You can write your answer in the chat. So sulfur has 16 electrons. So you try to see which one is the correct answer. Okay, so here we have Ming Chai show answer C, Yong Lok show answer B, then Julia B, Wu Xing C, Hun Long B, Hao Lai is C, Gao Ming Chai B, B for S guy. This one is what answer? Prishita is B. Hao Lai B7. What is it? What are you writing out, Hao Lai? Okay, so let's look at the answer. So the answer is B. Yeah? Okay, you can see here. So to construct the ground state electronic configuration, first we determine the number of electrons. Then we assign the electrons to the subcells following the alpha principle. Fill the lowest energy subcell first. Choice A and C should immediately stand out as wrong because you see A and C, you have 2D. We don't have 2D orbital, we just have 3D. Okay. Then C, you can see here, we have 2p7, but 2p maximum is 6. Okay. So choice D also wrong, okay, because sulfur is 16 electrons, so here only have 18. So the answer is B. Okay. Very good. For those who have answered already. Okay. Very good. Okay, so we look at the next question. Question number 5. Write the electronic structures of calcium ion and vanadium ion. Okay, so students, you can try to answer the question and write in the chat again. So maybe I have to give you the proton number, no? Okay, so for calcium, the proton number is 20. Calcium proton number 20. And for the vanadium is 23. Okay, so you try to count. So positive ion normally will accept or lose electron. Okay, so we have answer here. Okay, so Julia answer and Ming-Chai answer. Okay, so let's look at any more answer. Okay, we wait first. For vanadium, what's the answer? Okay, we have some more answer from X line. Then Go Yong Lok. Okay. Okay, going on. Okay, very good. Everyone had that. You can see. Okay, how about vanadium? Vanadium we have it for here. Okay, very good. Okay, so very good. So all the students can answer the question. Okay, so calcium after donate electron become the argon configuration. Become opaque. Okay. So vanadium is always donate the 4s first. Okay. So if you write 4s, then it's wrong. Okay. Must donate electron from the 4s first, because 4s after fill up, it will go up to the higher energy level. So donate the 4s and be careful. Students always make mistake. They remove the 3D. Okay. So must remove the, okay, like Jigu Shannon told you, remove the outermost electron accordingly. Yeah. Okay. Okay. So Ming-Chai, for the vanadium answer is correct. Very good. So now we look at question number 6. Write the valence electronic configuration of copper 2 ions. Okay. So copper 2 ions, copper proton number is 29. Okay, copper proton number is 29. So be careful. You read the question again. Just now is write the electronic configuration. So this time they ask you to write the valence electronic configuration. Okay, so valence. So when you answer the exam question, remember to use your highlighter or your pen to highlight the keywords. So valence electronic. So you just write the valence electronic configuration. Okay, anyone have the answer? Okay, 3s2, 3p6, 3d. Okay, so be careful. This one is copper. Copper, you have a night. Copper is in the D block. Okay, so D block. So we have answer from Wunlong. Okay, remember your D block, the valence electronic configuration. Okay, so extra you show all the electrons, so it's wrong. So this one, they just want the valence. So try again. Okay, so no answer. Okay, so I share with you the answer. The answer is not correct. Okay, so the answer is 3D9 only. You don't need to write 3s2, 3p6. Okay, okay, you can see here. So copper has 29 electrons at the atom. So -2, donate to electron. So got 27. Okay, so you have to consider the argon one. Argon is 18. Okay, so you have 3d9. So you just write for this one 3d9. Okay, so remember that. So for D block, the valence electronic is 3d4s. Okay, and D and S. Okay, so the 3s2, 3p6 no need to show. Okay, so next question. Okay, this one is a question form. Okay, question. Okay, iron forms a stable correct FeCO2, which is the following is the correct electronic configuration of the iron cations. Okay, so the question not straightforward. So you have to see here FeCO2. So what is the charge? Okay, so which answer is correct? Okay, so you have to choose Fe2 first. Okay, FeCO2, so Fe2 plus, so which is 24 electrons. Okay, so what's the answer? A, B, C, or D? Okay, so anyone has the answer? Okay, so D, so most of the student D, okay. So let's see whether your answer is correct. Okay. Okay, very good. Congratulations. So all the students can answer correctly. Okay, now we look at question 7. The number of electrons in an ion Q2 plus is double the number of electrons in an aluminium atom. What is the total number of electrons of Q atom? Write the electronic configuration for Q2 plus ions. Okay. So again, the question is not straightforward. So you have to see here, aluminium atom. So the number of electrons is double the number. So aluminium, the proton number is 39, remember? Proton number is 13. So calculate what is the total number of electrons of two atoms. Okay, after that, write the electronic configuration. Okay, so there's one answer here. Okay, answer here. So 28 correct, 28, 28. Okay, then the inside what the electronic configuration only. Okay. So let's see the answer. Okay, so very good inside. So you have 20, or not 28, 26. 2 times 13 is 26. Okay. So 26 electron and not 28. Why so many students like 28? Okay, so 13 times 2, 26. I think you're typing that's why I said 13. Okay, 13 double is 26. Okay. Okay. Never mind, maybe you careless. Okay. Okay, so very good, and the configuration all correct. Okay. Okay, now we look at question 8. Atom is at 28. Okay, let's see the answer question again. Oh yeah, it's atom. Okay. Oh, yeah, correct. That's why everyone answered 28. Okay. So the question here, answer here is wrong. Okay, very good. So it should be 28. 28. So number of electron is double the number atom. Okay. So the answer here should be 28. Oh, very good. Okay. So here got mistake. Okay. Mistake here. So 28. Question the answer here. Okay, I'll go back. Okay. Answer question again. So should be plus have to plus 2, huh? Okay, so you are right. 28. So 28. Okay, very good. So you all correct the addition mistake. Okay, now we look at the last question for today. Question number 8. The proton number of chromium is 24. Write the valence electronic configuration of the chromium atom and the chromium 3 ions. Okay. Then draw an energy level diagram of the orbitals to show the fillings of electrons in the valence orbitals of a chromium atom. Okay, so you try to do for chromium. Again, it's valence electronic configuration. Okay, any answer? Okay, so any answer from those students? Okay, so we can answer from inside. Okay, for each one. Okay. So inside, be careful. The question say valence electronic configuration. Okay, then Julia. Okay, Julia answer 3D54S1, 3D3. Okay, correct. Okay. So 3D3 for S1. Okay, so we look at the answer. 3D54S1 for the atom, then donate 3 electrons. So must always donate from 4s first. So 3D3. Okay. Then the energy level diagram. So just draw the valence one. Okay. So fill in 3D singly, then 4s. Okay, so for those who answer correctly, very good. Okay. Oh, I think I have one more question. Okay, one more question. Which one of the following represents the electronic configuration of the 3 electrons of highest energy for the ground state of an element in group 13? So you see carefully as the question say highest energy. Okay, highest energy element in group 13. Okay, so any question, any answer from the student? B. Okay, we have answer D. What else? Any more answer? Okay, very good. So most of the students can answer B. So correct. So highest energy level, you have to choose the highest one. Principal quantum number. So 4s2, 4p1. Okay, congratulations. All can answer the question. 3 valence electron. So you must choose 4s2, 4p1. This one is different energy level. For answer A, cannot be the answer. Okay, still have a question. Okay, question 10. An atom M has 7 valence electrons and form a stable M2 plus ion in an aqueous solution. What is the electronic configuration of atom M? So you see here, 7 valence electrons form a stable M2 plus ion in aqueous solutions. Okay, anyone have the answer? So this one is transition element. Okay, they shall not give you some transition elements. If you group 17, 7 valence electron is cannot form 2 plus ion, right? Okay, so transition elements, which one do you think is a transition elements in the answer shown here? Okay, B. Let's try answer B. Okay, any more answer? Tajiba also B, Okay. Because of the time, so I show you the answer. Okay, so we have question. Then its answer should be C, okay? So you can see here. Like just now the valence orbital of transition, like I told you, must have the ND and NS something like okay. So this is a valence orbital. 3D 5, 4s2, 5 plus 2, 7. So 7 valence electron, okay. So you can donate 2, okay. After you donate 2 electron, it will become 3D5, right? So 3D5 is extra stability, okay. Okay, any questions? So I think that's all for the so this one I don't show. Okay, I show very fast. So this one I show you is because it's an essay question. Okay. So normally they will ask you to describe how you apply the principle and the example. Okay, so you describe now. Okay, by let's say apply the Pauli exclusion principle. Then you means you have to fill in from the so for same orbital must fill in opposite spin. Okay. Then step 2, apply the alpha principle, fill in the 2s orbital. Okay. Then step 3, fill in the fill in the regenerate orbital single because with parallel spins before fill in case. Okay. So this is a essay question, and so you have to use an example and explain how you apply the principle. Okay, so summary for today's lesson. So you should have learned learn how to reduce the number and relative energies of the s, p, and d orbitals for the principal quantum numbers 1, 2, and 3, including the 4s orbital. Describe the shape of the orbitals, predict the electron configurations, and define the principle, apply the principle. Okay. So thank you very much, students. So sorry for any mistake for today's lesson. Okay. So I will share the links now. Okay. So you have to fill up the links in 30 minutes. You have to use e-delete accounts. Okay. So if you haven't applied the e-delete account, you can look at the link above, which I have shown above. Okay. Or in the description also you can find the link. Okay. Okay. Thank you very much. Okay. So that's all for today. Okay. Bye bye.
Semua sekolah ditutup hingga cuti akhir tahun 17 Disember 2020. Anda tak cukup bahan? Tak ada rujukan? Tak faham? Anda nak tuition tapi PKP? Jangan risau, kami di Akademi YouTuber dengan kerjasama Kelab Guru Malaysia dan e-didik Malaysia mengadakan kelas tuition online. Semua peringkat ada, semuanya secara percuma. Video PDPC pun ada. Apa ditunggu lagi? Layari www.academyyoutuber.com. Dibawakan kepada anda oleh Akademi YouTuber.